Hello, madam.
Okay, so today is our last session for this workshop. I hope you had been enjoying the workshop till now and you will continue enjoying this last session. ERF will join with you the link to the Dropbox, to the do file and the data files that we'll be using today. So we had just to change the order of the workshop. So yesterday you saw with Chahir, Zaki, panel data and the techniques related. Today we will continue with another method that we can use in order to overcome the problem of non-randomization, as we discussed last Tuesday, to see how we can overcome. So what we saw last time was together with the PSM, and we said that it's mainly overcoming the problem of randomization based on observable characteristics. What are the characteristics that we can observe and we can control for? However, we discussed together that we know that there are other unobservable characteristics that can affect the selection of individuals in a specific program or a specific treatment, and also can affect the outcome of the individuals. And this is what we'll try to do today using the difference in difference technique. So let me share my screen. Can you see the presentation?
Yes.
Okay. So here, let's start with this idea. Assume that we have 2 points in time. We have in the middle the treatment. So if I will take again the example of Takaful program in Egypt, which was implemented in 2015. So assume this is the year 2015. So we can have 2 points in time, one point before and one time after, okay? And we have 2 groups of individuals. We have the individuals who had been treated, I will call them B here, and individuals who had not been treated, who had not been participated in the program Takaful, and I will call them A. So over time, between the period before 2015 and after the period 2015, we assume that individuals, because they already have different characteristics, observable and non-observable, will have 2 different, their situation would evolve. Assume that the outcome in this case is the income. Okay, so assume that group A and group B had their levels of income different in the years before 2015, before the treatment or before joining this group. Okay, B had already a higher income level than A, and if nothing changed over the time, B will continue having higher level. So here in this point, B prime is higher than A prime because the 2 groups of individuals had already different characteristics, and they will be supposed to have equal trend in their income. But due to the treatment, we assume that the treatment group will have even higher level of income because of their participation in the program. So instead of having B prime, they will have this level B double prime, and the difference between both will be the treatment effect. So again, we had already 2 points in time with 2 groups. The 2 groups have different outcomes in the period before the treatment or before the participation to the program. And in the absence of the treatment, both they are supposed to be, or their outcome is supposed to increase or change in parallel trends. And B prime will continue to be higher than A prime. However, because of the treatment, the beneficiaries group or the treatment group will even have higher outcome. So in this case, higher income. If we are talking about women empowerment, will be more empowered. If we are talking about the nutrition of children, will be better nutrition. And we can say that the difference between B prime and B double prime, this increase than what is supposed to be the situation is due to the treatment effect or due to the fact that this group of individuals participated into the program. Okay. However, it's possible that there is a bias because the individuals, as we said, they are not randomly selected to participate in the program. Because we see that from the beginning, the group who had been benefiting from the treatment have different characteristics, observable and non-observable. And this makes that they would already be, so here this was B prime, this point was B double prime. So even without the program, the individuals of the group B were supposed to be at this point, which I will call it Z, for instance. So without even being participant in the program, because of the difference in characteristics between the two groups of individuals, we can expect that their outcome, whatever this outcome is, income or women empowerment, was supposed to be at the point Z, not B prime. And instead of Z, it is at B double prime. So this means that the treatment effect is only the difference between B double prime and Z. So if I compare the two graphs here, you see that the treatment effect is very large. So if I wanted to provide recommendation to the government, I will say yes, that the impact of Takaful program is very important on income or on women empowerment. However, there was a bias because of these characteristics that we cannot observe, and the difference related to the treatment or to the participation in the program is this only small part. There is effect, yes, there is effect, but it is much lower than what we conclude from the beginning if we did not control for the bias. Okay, so this is why, again, as we discussed in the PSM, we need to control for this bias to be sure that the effect of the program is related to really the program and not to any characteristics, observable or non-observable, in the treatment or in the beneficiaries that makes them already better off compared to the control group. Is it clear, this idea?
Just a question, Racha, please. So when you talk about the treatment, generally, should the treatment be in the same year for all observations? For example, let's say Egypt gets an IMF package in 2016, Jordan in 2017, Tunisia in 2021, etc. Can I still use difference in difference if like the treatment takes place for different observations, different countries in different years, or should they be in the same year?
I mean, it should be in the same year because it would make a difference. For instance, if you want to compare individuals in Egypt before 2016 and after 2016, let's say we'll take 2 years before and 2 years after. If you do the same thing for Jordan, it will not be the same period. So you assume, and generally you compare it for the same country because you can have even more characteristics that would affect the outcome if you compare between different countries, because it will not only be individual characteristics, but also will be other country characteristics. So you suppose that you have the same year of implementation and you compare before and after this years of implementation, just to be sure that the period of the treatment or of the whatever program you are applying is the same for everyone. So you are not compare someone who get benefit of this program for 1 year and others for 2 years, while others did not benefit at all.
So we can use panel data insofar as the treatment happens in the same year?
Yes.
Okay, thank you.
And usually, I mean, in your panel data, as we'll see also in our example. So for instance, if I will take an example in Egypt, if I will take the ELMPS data, you have for 2012, okay, and there had been I don't know, the Takaful program in 2015, then you will have another round of the panel data in 2018. So now in everyone in Egypt, all individuals, the program was implemented in the same year, and you have one round of the panel 2 years before this implementation year and 2 years after the implementation year. So here you can compare between both.
Sure, thank you.
Okay, thank you. Okay. So the main idea or the identification assumption, we have strong assumption and we have weaker assumption. So the strong assumption says that the treatment or placement into this program, whatever this program is, should not depend on unobservable characteristics. Why? Because these unobservable characteristics can affect our outcome of interest. If you remember when we were talking about the PSM, we said that we can have some observable characteristics like age, like sex, like geographical location that can affect the probability that the individual will join the program, and in the same time will affect their outcome. So for instance, there is another program in Egypt called Forsa, which is related to, it's like training programs for individuals benefiting from takaful in order to integrate them into the labor market. So the characteristics of individuals that would affect the likelihood to join the program Forsa can be the same characteristics that would affect their income, which I want to improve. So the outcome in this case is the income level of individuals, and the treatment or the program I want to study is the program Forsa. So with PSM, we assume that the same observable characteristics can affect the likelihood of joining Forsa and in the same time affect the income level. And to be sure to have to overcome this problem of non-randomization, we controlled for all the observable characteristics as we discussed. Here we said that in addition to these observable characteristics, we can have other unobservable characteristics that can affect both the outcome and the likelihood of joining the program. So this first condition, exogeneity of treatment assumption, really verified, because we know that if they are not selected randomly, there are some unobservable characteristics, their skills, their attitude, their beliefs that can really affect both outcomes. So to overcome this, or to we can have like weaker assumption. In this weak assumption, we will decide to distinguish between two kinds of unobservable characteristics. There are some unobservable characteristics that can vary over time, okay, that can change over time. If I will talk about my skills, it may improve over the years between 2012 and 2018, but there are other invariant unobservable characteristics that would not change over the years. Of course, the characteristics that are varying over the years, I cannot really control for, because if they are varying and I cannot observe, it's not really a way to overcome it. But the fact that we have panel data and we will use a difference in difference method I will talk about, this will allow us to control for these unobservable characteristics that I cannot observe, but in the same time, it would affect the likelihood or the probability of being selected into the program, and in the same time, my outcome. So by using the difference in difference, this method, the techniques that we'll study, and getting benefit of the fact that we have 2 points in time for the same observations, this would allow us to eliminate or remove this time invariant unobservable characteristics. So this is why we said that diff and diff is different from PSM, that it can control for the unobservable characteristics, and we will talk at the end that we can even use both to control for, or to, so using the two techniques would allow us to overcome this problem of non-randomization, okay? And by using this weak assumption, by distinguishing between time invariant unobservables and time varying unobservables, we can say that selection would depend on time invariable unobservable, but this will be eliminated by the difference in difference method. And we assume that the selection into the program will not depend on time varying unobservable. Okay. So with PSM, we just focus, or we controlled for the observable characteristics. With the diff and diff, we will control for the time invariant unobservable characteristics, and it will remain the time varying unobservable characteristics that we cannot control for with these two techniques. So let's take this example in order trying to see what is the main idea of or what is the main idea or logic behind the diff and diff method. So now we have two groups, as we discussed. Treated group, I will assume this is the group who benefit from Forsa program, and the control group is the group of individuals who are not benefiting from Forsa program. And we have 2 points in time, outcome of interest before this treatment or before the selection into the Forsa program, and another point after the selection. And we have a given outcome of interest. I will assume that this outcome of interest is the income. So I want to compare between income of individuals who benefited from Forza program and income of individuals who did not benefit from Forza program. Okay? Let's assume that the income level of individuals who are treated before Forza here, the difference between both is the Forza program. Let's say this in 2012 and this in 2018. So A is the income level. So our outcome of interest is YI, the income level. A is the outcome or income level of individuals who joined Forza program in 2012. And B is their income when they joined the program after the program in 2018. And C is the income level of the control group, and D is the income level of this control group after the treatment. If you remember the first graph, if I will return to the first graph here, so in all cases, given the difference in characteristics between the two groups, the income level of the control group is supposed to be higher than the income level of the the income level of the treated group is supposed to be higher than the income level of the comparison group or the control group, even without the treatment. But now I want to know if it's even higher with the treatment, it's even higher by joining the program Forza or not. So this is what we want to compare. First method to do or way to apply this is what we call the first difference. This if the conditional exogeneity of treatment, the strong assumption is verified. If the strong assumption is verified, if I recall it that the selection into the program and the outcome are not affected by unobservable characteristic, so this stronger assumption, if it is verified, in this case, we can simply compare between the outcome of interest, which in our example is the income of the treated group and the control group after the treatment. So all what I have to do that in the year 2018, after being benefiting from the program Forza, I will compare between the income level of the Forza beneficiaries and the income level of the non-beneficiaries. And the difference between both, this would be the treatment effect. This would be the impact of the Forza program on the income of the individuals who benefited from the program. But as we know, this first difference approach is applied if the conditional exogeneity of treatment is verified. If we know that there are no unobservable characteristics affecting the selection into the program and the outcome in the same time, which is not really verified or is not always the case in the application if it's not randomized. This is why instead of using the first difference approach, we used what we call the difference in difference approach. What is the idea of the difference in difference approach? So here it is verified under or can be used under the weaker assumption that we assume that or we differentiate between unobservable characteristics that are not varying over time and unobservable characteristics that are varying over time. And here we will need to compare the difference between the outcome of the beneficiaries and the non-beneficiaries group, and the difference between the outcome between the control group and the treatment group, the difference between these two differences, which we call difference in difference. Let me show you the table. So here, this is the outcome of the treated group before the treatment, and here this is the outcome of the treated group after the treatment. I will calculate the difference in between this. So Racha is benefiting from Forza. I will calculate the difference in Racha's income after her benefiting from Forza with before benefiting from Forza. So this B is my income in 2018 minus my income in 2012. So this is the first difference. And then with the control group, I will do the same thing. Hussein is not benefiting from the program, so I will calculate the difference between his income after the outcome, after the Forza program, and his income before the Forza program, Z minus C. The difference in difference, the effect of the program Forza on the income level, it would be the difference of these two differences. The difference in the outcome of Racha due to over the years, minus the difference in the outcome or income of Hussein over the years. And the difference in these two would be our effect that we are looking for to see if it is positive. This means that Forza had positive effect on the income level of the beneficiaries who benefit from the program Forza. Is it clear, this idea? Okay,
Yes.
so this, yes, okay, perfect. So this is what we call difference in difference. And again, this technique or the second difference approach is based on the idea that the bias selection is based on observable characteristics, as we discussed in the PSM, and unobservable characteristics that are time invariant. So we can control for both. However, if there are any unobserved characteristics that change over time, we will not be able to overcome it or to control for. Let's see how we will estimate or get this difference in difference or the effect of the treatment on the outcome using the difference in difference method. So difference in difference method estimates the average program impact as follows. Here you have the outcome of the treated individual at period 1 minus the outcome of the treated individual in period 0, given that the individual is treated. So if I read in period 1, so period 1 is a period after the implementation of the program, and period 0 is the period before the implementation of the program. So this expected value, this example is the example B minus A, the outcome of the treated group of the outcome of the treated individual after the program minus their outcome before the program, okay? Minus the expected outcome of the individuals who are not beneficiary from the program, the control group at period 1, minus the outcome of the individual who were not benefiting from Forza program at period 0 before the treatment, okay? And assuming that these individuals are not treated or not beneficial. Of course, if we assume that it is random and the counterfactual group, the individuals who had not benefit from the program should not see their outcome change over time, in this case, the second part will be equal to 0. Okay, so under this assumption, if we assume that the outcome of the individual, the income of those who did not benefit from Forza program should not change because they did not benefit from the program, in this case, this part will be 0. And simply, I can say that the effect of the Forza program on individuals is the difference between their outcome in the period after the implementation of the program minus their outcome before the implementation of the program, given that they benefit from the program. But which was in what I said is called the first difference, the difference between my outcome before and after the treatment. However, as I said, this is not always hold in practice and is not likely to happen. So how we will overcome this? We will overcome this by trying to calculate the difference in difference. This difference between the difference in outcomes of the beneficiaries and the difference in outcomes in the non-beneficiaries over time. How we will do this using the data? So we have different steps. The first step, I will regress the outcome of interest, which is in my example, the income level, on 3 things. I will regress it on the time dummy, because we know that over time, the outcome can change. So I will regress it on a time dummy variable. I will regress it on treatment status to differentiate between those who had been treated and those who had not been treated. And I will regress it also on the individual, on the interaction between these two dummies. In other words, my outcome variable for individual I at period T equal alpha, which is my constant, plus gamma T, which is the treatment of the individual I at period 1. And it's at period 1 because we know that at period 0, there was no treatment. Plus delta multiplied by T, and this T is the time dummy, plus beta multiplied by the interaction between the treatment dummy and the year dummy, plus our error term. So again, yi is my outcome of interest for individual I at period t, which is in our example is income. When t equals 0, this is before the treatment. When t equal 1, small t, this is the time after the treatment. And ti 0, the treatment situation of all individuals I at period 0 equals 0, because at period 0, there was no treatment at all for anyone. Okay? Let's now calculate several expectations. The first thing I want to calculate the outcome of individual I before treatment if the person is not treated. Again, I want to calculate the expected value of the income of an individual I at period 0 if this individual will not benefit from the program FORSA at all. According to this equation, according to you, what will be the expected value of the outcome of this individual at period 0 if we know that this individual did not benefit from the program at all? Would you please tell me what you think will be the answer? Again, I wanted to know what will be the expected outcome of individual I at period t when t equals 0, and this person will not benefit from FORSA at all. So what would be the expected value of YIT when t equals 0, given that this individual will not benefit from the program at all? Equal what, given this equation?
Equal to 0.
0?
It must be the intercept, no?
The intercept, yes, because alpha is not multiplied by anything, so it will be alpha plus you have gamma multiplied by TI1, but we know that this individual is not treated, so this one will be 0. At period t equals 0, so this also will be 0, and the interaction between 0 and 0 will be 0, and because it's expected value of our error term, as we saw in the first session on Monday with Chahir, that it will be should be equal to 0. So in this case, the expected value of the outcome of an individual at period 0, if this individual will not benefit from the program, will be alpha. Okay? Would you please write in your notes alpha, because I will want you to use this answer to answer another question later on. Okay, now I want you to calculate the, so I will remove this one, I wanted to know what would be the outcome of an individual who is treated. Okay, so I know that individual will benefit from the FORSA program, but I want to know what would be his expected outcome or expected outcome in the period t equals 0. And let me erase the answer. So would you please tell me what would be the outcome, the expected outcome of an individual who will benefit from FORSA, but I want to know it at the period t equals 0, which means before the implementation of the FORSA program? Any idea, any suggestions?
I think equal alpha plus gamma
plus gamma
plus sigma plus beta.
You mean plus delta? This is delta. Plus delta
yes.
plus beta?
No, plus beta. Plus beta.
Okay, so let's go step by step. So alpha, yes, because alpha is not multiplied by anything. So it will be alpha plus gamma multiplied by t, and we know that t capital at period 1 for this individual is 1 because he is a beneficiary from the program, so it will be plus alpha plus delta multiplied by t for period, and the t we know that the period is 0 because it's the period before the implementation of the program, so this one will be 0. But here you have the t capital 1 because the individual is beneficiary, but we wanted to calculate it at the period t equals 0. So here is 1 multiplied by 0. So all this part will be eliminated. So the expected outcome of an individual who will be treated by the program, but at period 0 will be equal to alpha plus gamma. Okay? So again, the expected outcome of an individual who will not be treated at period 0 will be equal to alpha, but the expected outcome of an individual who will be treated at the period t equals 0 will be alpha plus gamma. Do you all agree on this?
Yes, Rasha, I agree with the math, but the interpretation. So you say that the expected value of the person. What exactly do you mean by the expected value of the person? Because I'm not really confident about what the dependent variable.
Outcome. The dependent
Okay.
variable is whatever outcome you are interested in has. So in this example, I am assuming that it is the income level.
Okay.
Okay, so here's the expected value of the income level of the individual I who will be benefiting from the FORSA program, but his income at period 0 before joining the program will be alpha plus gamma. Of course, if we have data, as we will see in the second part of this session, we can estimate the value of this alpha plus gamma, right? Because we will have the values of the outcome level, as we will see, and we'll have all the information regarding if he is treated or not and what period it is. Is it clear now? You are more comfortable with this?
Yes, thank you.
Okay. Now I want you, so please again write it. So the expected outcome or the expected income of individual who is benefiting from FORSA, but before benefiting from the program is alpha plus gamma, while the expected outcome is expected income of an individual who will not benefit from FORSA before the implementation of the program is alpha. Okay. Now I want you to calculate. Now I want you to tell me what is the expected value of the outcome of an individual I at period t equal 1, which means after the implementation of the program, when this individual is not benefiting from the program. So what would be the expected outcome, which is in our example is the income of this individual at the period t equal 1?
Alpha plus gamma.
Alpha plus gamma, this one?
No, the second.
The second, this one, delta.
Ah, yes.
Yes, delta.
Sigma.
Okay. No, delta. This-
Delta, yes, delta.
Yes. Yes, so as Rashida said, so it will be equal alpha because alpha is not multiplied by anything, plus gamma multiplied by T capital, which is a treatment, but I know this individual is not treated. So T equal 0. So this one will be eliminated, plus delta multiplied by T for the time dummy. And we know that we are talking about the expected outcome at period T equal 1, which means after the implementation of the program. So it will be delta by 1, which 1. And the third one will also be cancelled because you have 1 multiplied by 0. So it will be alpha plus delta. Okay. So in this case, the expected outcome of an individual who will not benefit from FORSA program after the implementation of the FORSA program will be alpha plus delta. Okay. Do you all agree on this one? Okay. I will assume that this silence means yes. Please write it also. And now the exercise I want you to do. What would be the expected outcome, which is in our example, the income level of an individual I at period T equal 1, which means after the implementation of the program, when TI equal 1, when this individual is benefiting from the program, equals what? What is the expected income of Russia in the period of 2020 after the implementation of the FORSA program when Russia is benefiting from the FORSA program?
This is the sum of the coefficients except the
Yes.
epsilon at the end.
Exactly. So it will be alpha
Yes.
plus gamma
Gamma plus
delta.
delta plus beta.
Exactly. So it's simply will replace all the T capital and T small by ones, and we'll get alpha plus gamma plus delta plus beta. I hope you wrote this in your notes. So now I will just show you the same thing we're doing. The expected outcome of Rashida, and Rashida is not benefiting of the Forza program in 2012 was alpha. The expected outcome of Racha in 2012, while Racha will benefit from Forza, is alpha plus delta. And the expected outcome or income of Rashida at period 2020 after the implementation of Forza, while Rashida is not benefiting of the program, is alpha plus gamma. And the outcome of individual Racha after the treatment in 2020, while Racha had benefit from the program, as you mentioned, alpha plus gamma plus delta plus beta. Okay, so we did good job. Now I want you to calculate this table. What would be the difference of the outcome of Racha, given the coefficient you wrote, in between period 2020 and period 2012? So if I will repeat the same things, here it was alpha, here was alpha plus gamma, here was alpha plus gamma plus delta plus beta, and here was alpha plus delta. So now B minus A would equal what? So I'm just here substituting the examples we gave A, B, C, D by the expected values we calculate from our equation. Okay? Is it clear what I'm doing?
Yes, yes.
Yes.
Okay. So now my question,
Delta,
B minus A equal what? So can you repeat please?
delta plus beta.
Delta plus beta. Exactly. If we subtract B,
Yes.
A from B, we'll get delta plus beta. And D minus C equal what?
Delta.
Delta. So the difference in the income of Racha over the years between 2020 and 2012, given that Racha benefit from the Forza program, is delta plus beta. And the difference in the income of Rashida between the 2 years, 2020 and 2012, given that Rashida did not benefit from the program Forza, is delta. Now the the DD that we are looking for is equal to what?
Beta.
Beta.
Exactly, beta. So this is the treatment effect we are looking for. We want, if I will return back to my regression, I wanted to know the value of this coefficient, and this value of this coefficient will tell me what is the effect of the program Forza, my treatment, on the outcome of interest, which is in our example is the income level. So the treatment effect is the DD, the difference in difference, and the difference in difference in this case is beta. But keep in mind that this under the weaker identification assumption, that we assume that the selection to the program is not affected by the unobservable characteristics that are invariant over time. And in this case, the average treatment of the treated or the effect we are looking for is the coefficient beta. And this is a coefficient simply of the interaction between the time dummy and the treatment dummy. And this is how we can benefit from the fact that we have panel data that we can control for the observable characteristics and the unobservable characteristics that can be invariant over time. Okay. However, you have to keep in mind that, here in this regression, we are only controlling for the time dummy and the treatment dummy, yes? But as we saw in the PSM, we can have other individual characteristics that can affect the selection into the program and can affect also the outcome of interest. My income is not only affected by time and by being participant in Forza program or not, but my income also is affected by my age, my sex, my years of education. So we can simply introduce other covariates, other regressors that we know that it can affect my outcome of interest. And even if we control whatever, we include whatever characteristics, we have to keep in mind that the average treatment of the treated or the effect of the treatment we are looking for is only beta. So even if we control for X's, yes, it's good because it will allow us to control more covariates and more variables, but observable variables that we can measure. However, it will remain the same thing. The coefficient beta of the interaction between the time dummy and the treatment dummy is the variable, is the coefficient we are looking for. We can assume that the effect of the program will vary with the observable characteristics. For instance, I can assume, or I want to test, if being a female participating in Forza program would have an effect on my income different from the fact that a male person is participating in Forza program. So if I want to see if the sex would have different effect on the impact of the program on my outcome, I can simply interact the treatment effect and the interaction between treatment and time effect with the explanatory variables. If I assume that individuals in rural areas will benefit more from Forza program compared to individuals from urban areas, so I assume that the effect of Forza on the income of individuals in rural areas is different from the effect of Forza on income of individuals in urban areas. I have simply to interact the treatment dummy and the treatment and time dummy with the urban-rural variable, okay? And this we'll see it in SATA, that we can add the interaction to see if we have heterogeneous effects based on other characteristics or not of this program or of the treatment we wanted to control for. It's possible that if we don't have a panel data, we wanted to use the difference in difference, but instead of looking at difference over time, we'd look at difference over regions or geographical area. So this is sometimes the case where we can use difference in difference technique using cross-sectional data, not panel data. It's not so common, but still you can apply it, and we will see how we will apply it in the SATA example we will study. So in this case, SATA, difference in difference will not be across groups of individuals with, it will be again across group of individuals with group who have been treated on or benefiting from the program, and another one is not other group of individuals who are not benefiting from the program. However, it will not be over time, it will be over geographical areas. So in this case, for instance, I said, okay, assume that Egypt has 25 governorates. Assume that the program had been applied in only 10 governorates. So the 10 governorates where the program had been applied will be considered as the period T equal 1, the period where the program was implemented. And the other 15 governorates where the program was not applied will be considered as the period 0, where the program was not applied. Okay, so here I will not compare between T equal 0 and T equal 1. No, I would compare between governorates or villages where program had been applied and governorates or villages where program had not been applied. Okay, and instead of participants and non-participants, I can simply compare between households who had been targeted to benefit from the programs and households who had been non-targeted to benefit from the program. So I will consider this as participant and non-participant, okay? Because, I mean, here we are targeting, we are not sure if they will participate or not. So I will consider them as participant and non-participant.
Excuse me, Racha.
Yes, Hassan.
Why can't we use the PSM method to do this? I mean, if we use dummies for the different regions and still use the PSM, wouldn't this work? Instead
Yes,
of using... Okay.
Yes,
okay.
you can use the PSM. Yes, and this is what I was saying, that usually if we use it for time for panel data, but in case you wanted to try it, or you want maybe you use the PSM, but you wanted to check with another method, so you will use also difference in difference. But I mean, you are right. Okay. You can use, in this case, in cross-sectional, it's much easier to use the PSM.
Right.
And yes, so here the difference in difference will not be, so it will be the difference in the outcome of the targeted individuals or the targeted household in villages where the program is applied and in villages where the program is not applied, okay, minus the difference in outcome of non-target individuals in villages where program was applied and in villages where the program was not applied. So here's the same idea of our table with the ABCD, but instead of having over time, we'll have it over villages. This is a typo. Let me remove it. Okay. Another thing that we can do, and this is what I mentioned last time, that sometimes it's even more beneficial. I mean, if we want, we know that PSM control for the observable characteristics, the diff and diff control for observable and unobservable characteristics that are not varying over time. We can use both both techniques on the same data to be sure that we are controlling as much as we can on the issue of non-randomization and our assumptions that have not been verified. And here what we will do is that we will do the PSM on wide data, and I will come in a moment about what is the wide data and long data. So we will see what are the observable characteristics that would affect the outcome of individuals and affect the probability of being selected into the program. We will use the PSM. We will calculate the P score for these individuals. Then, as we saw last time, we will use this value, this score, instead of doing the matching, but as a weight for the diff and diff regression. If you remember last time, we said that I can calculate the P-score for all individuals and then match between individuals who had been treated with individuals who had not been treated, right? And we said that there is another option that I can run a regression with a dummy variable for the treatment, but to control for the non-randomization, I will use the P-score as a weight, not as a way to match between treated and non-treated individuals. So here we can do the same thing. We will use the pre-treatment characteristics, the observable characteristics that we use in PSM. We will calculate the P-score. We will use the P-score to calculate the weight, as we saw last time and as we will see also today. Then I will estimate my D&D regression, and the coefficient beta will be the coefficient that we are interested in, which is the coefficient of the interaction between treatment and time dummies. However, using the weight of the P-score will allow me to get benefit on the methodology of PSM. And here we are using both methods. Any question till here? Is it clear? Okay. So now, before you going to the Stata application, we wanted to know, because the structure of the panel data is different from the structure of the cross-section. When we used cross-section, we saw that we had the observations in one point of time. We have the observable characteristics, so we apply PSM directly. However, the structure of the data in the difference in difference is that the advantage of having a panel, of having the same observations, same individuals or same households observed over time, as you saw, I believe, with Chahir yesterday. So we have our variables of interest at period for point I, for individual I, in period G or in period T, if it will be easier for you to look at this. And we can have all type of characteristics, employment, status, income, place of residence, sex, age, education level, everything, okay? Of course, we know that we have some variables that are time varying and they can change over time. My employment status can change over time, my income, my education, my place of residence, I can be living in rooms into it. And some other variables are not supposed to change over time, like sex, for instance. And of course, you have to, when you are working with your data, you have to be sure that there is no error term. For instance, if someone had I don't know in 2012 had 20 years old and in 2018 have 18 years old, this means that something wrong. Or someone who had 20 years in 2012 and 20 years in 2020, this means that there's something wrong. So you need to be sure that things who are not supposed to change over time are really fixed over time, and things who change over time, yes, you can observe that they are changing over time. And if there is something that doesn't make sense, this means that maybe this data entry error and you have to correct for it. The data, and I am not sure if I think you discussed this with Chahir yesterday, is that you have long data and wide data. So for the long data, as we will see, you have for each year or for each period in time, a line. So you will observe Russia in 2012 and Russia in 2018. While in the wide data, you will observe for Russia only one line, and you will have all her variables over the year, as I will show you in a moment. Let me just open the setup file so you can my screen again. I don't know why I have this here. Can I move this? Okay. I don't know what I move. Okay. So here's the data set we'll be using after the break with or I can also even start now and then take a break later. So here, as you see, we have long data. So we have the NH is the household identifier. Here we are working at the household level. And you have, for years, you have 2 points in time, 0 and 1. So you see that for the long data, the household 11054, we have 2 lines. For the household 11061, we have 2 lines. For the household and for all the other observations. Okay, so this is a long data. We can transform this data from long to wide using, so here it's how it looks long. And as you see, the variables who are not supposed to change over time should be constant over time for each 2 years. And for the variables who can change over time, you can see the value changing over time. So this is the long data. For the wide data, as you can see, the variables who are fixed over time have only one value. So we have sex only variable, will not have sex for 80, 81, 82. While for the income, we're supposed to change over time. We can have it over the different periods that we are studying or having in our analysis. You can move from one shape to another shape using the command reshape, as we will see. And sometimes you can have, I mean, if you have a duplication, for instance, 2 lines who are exactly the same, and this means that there is only error of data entry, it will not be able to do the reshape. It will not really accept to do the reshape. And in this case, you have to, you can use the command duplicate report, because this command will let you know if it is, if there is redundancy, just one line what is repeated twice or what. Okay, let me come to the data again. So to get our data today is from, so again, this do file is based on a do file that was originally created by Ragi Asad and Caroline Kraft, who used to give training. The data we use is from the Bangladesh household survey, and we have two, of course, is based on this household survey, but it is modified for the purpose of the training. We have 2 periods in time, 91, 92, and 98, 1990. So in the data set, what you saw, the year 0 is the year 91, and the year 1 is the year 98, 99. Okay. So the same individuals have been followed over the year, and you have in this data set information about 826 households that had been interviewed. and as the household level, and your variable of interest, what we'll consider as treatment or as a program that we wanted to study its impact is microcredit program. It's a microcredit initiative. And here they differentiate between two types of microcredits. There are microcredits only for men, and there is microcredit only for women. And we will see that, we'll study both, and we can see that it will have difference. So this means that microcredit program will not always have the same effect if it is for male or it is for female. And here we are already distinguishing between households where they receive only men microcredit, or the households who receive only microcredits for women. But this brings me to what I was saying in the presentation, that sometimes you want to distinguish the effect, or you assume that there is heterogeneous effect of the treatment that can change based on other characteristics as a sex, as a geographical location, as education level. So here you have to interact between the time dummy, treatment dummy, and the variables that you assume or you think would make a difference on the treatment. Okay. The survey is divided into 29 thanas, and thanas are the kind of sub-districts in Bangladesh. You have 24 in the survey, 24 thanas, and this was the thanas that had been targeted. However, there are 5 who had not been targeted, and this is important when we will try to apply the program on individuals who, on 1 year to see if we can use a diff and diff using geographical difference and not time difference. We'll see it also as an example. There was an eligibility criteria to decide who will take the microcredit and who will not take the microcredit. And the cutoff is 1/2 acre of land owned. So based on the land owned by the household will differentiate between those who benefit from the program and those who did not benefit from the program. Okay, so this is our data set. Here I am doing the same thing. I'm clearing the data set. If there was any data set, I'm specifying where I will put my, where is my original data and with my temporary data. I open a log file. I didn't show you the log file at the end last time. I will show it today. And again, because usually when you get the data, you need to be sure that your data is safe and whatever manipulation you will apply on your data will not affect your original data. So I always highly recommend to, after using that, you save it under another name, and you will save here. As usual, I highly recommend to start with the descriptive statistics of the data, or sorry, the description of the data. What are the variables we have? So here we have household ID, year, village ID, Sana ID. We have the characteristics of the head, age, sex, education. We have the characteristics of the household, like the family size, the land the household have, if they have asset or not. What is their per capita food and non-food expenditure, total expenditure. If they have male microcredit participant, yes or no, so this will be our variable of interest. If they has female microcredit participant or not. We have the sampling weight. We have other characteristics of the village, like accessibility through road, land irrigated, and the prices of different products. Okay, so these are variables we have in our data set. And you have all the values in monetary in the Bangladesh currency. Okay. We want, as I said, we want to check if we really have a panel data or we simply have, same line replied twice for any error or anything. So to do this, you can check using the command duplicates. So duplicates report, you can check it. You want to be sure that individuals or the households are unique. So you write duplicates report with the variable you want to identify if it's unique or not. And here you see that it tells you the results of the command that the household identifier is repeated twice. So we have each unique identifier of the household repeated twice. And this is expected given that we have a panel data. So expect that and this is long data. So we know that each observation will be observed twice. I can do the same thing using the two identifiers, the household and the year, to be sure that we have really panel data without any duplication. And here we have, yes, it tells you that you have one, I mean, if you use the year and the household identifier, so you don't have any copies, only one copy per these two identifier. Yes, you have 1652 observations and don't have any surplus. Here the surplus was for the second year. I mean, it was 826 for 1 year and 826 for the second year. So here we know that we don't have any duplicates or any redundancy in the lines, but we have a panel corrected data. Okay. Here the sample weight is a variable weight. We cannot, I mean, we can really move this sum. Okay, now I wanted to, as we discussed last time and on Monday in the first session, it's really good always to understand the data and to include some descriptive statistics that would allow you to better understand the data, to include in your paper to have a clarification of what is your sample, what are the characteristics of your sample. So here we will do this. As I mentioned, we have male microcredit programs and female microcredit programs. So we want to know who is benefiting, how many households are benefiting in this program over the years, and how many female households benefiting from the female program. So here I will do it. So over the 2 years, we have 12% of the households where they have a male participant in the microcredit program. Okay, if we do it for female, we have, you see that over the 2 years, we have 29% of the households have a female microcredit program, which means that female benefit, or there are more households benefiting from the female credit compared to the male household, the male microcredit. So this one of the things is important when you write your data descriptive, to understand what is the benefit, who is benefiting from these programs. We want to see if there are some households benefiting from the two programs. I mean, they have male benefiting from microcredit and female benefiting from microcredit or not. So here I can see that among households who have male participant in the microcredit program, okay, sorry, let's read it by column. Among households who have a female who participate from the microcredit program, 15% also benefit from the male microcredit program. Okay, so we have in some households not only female benefiting from the program, but also male benefiting from the program. We can do the same things over, just to show you the command that you can tabulate variables size if you wanted to have the analysis over row or over column. So I can do this. And here, among male households or among households who has male benefiting from the microcredit program, 38% of this household have also a female benefiting from the microcredit program. Okay. One of the things that we can start with, if I wanted to compare, so here my outcome variable of interest will be total per capita expenditure, okay? And my treatment or my program is having a male participant in the microcredit program or a female participant in the microcredit program. So our outcome variable of interest is per capita expenditure, and it is measured in the Bangladesh currency taka. We can start simply, I mean, yeah, it's not like doing the difference in difference or PSM, but I can simply trying to compare the average total per capita expenditure of the household who have beneficiaries with the average total per capita expenditure per year of the households who have no beneficiaries. So simple comparison of the mean of my variable of interest to see if there is a difference or not. I want to see if there is a difference between the mean of these both variables or not. The variable of interest, as I said, will be the per capita total expenditure. So we have 1652 observations. The minimum value is 1193 taka, and the highest value is 47,981 taka. Okay. Now I want to, if I return back to my data, here you see that. Let me show you that the variables of interest. So here you have the household identifier, the year, and the total expenditure per capita. Okay, and we have it in long form. I will use another way to differentiate. I mean, now I want the total expenditure for the year 92, which is year zero alone, and the total expenditure of the year 1, which is 98, in a separate column. To do this, I will create a total expenditure variable from the year 1991. So I will create new variable. I will call it expenditure total 0 equals the value of the total expenditure if the year is 0 or the year is 91, the first year before the implementation of the program. Okay. Then I will create another variable. I will call it expenditure 91 equals the value of the total expenditure of 0 for each household, the maximum, because if you see what I created here, I always like to open the data after each command I run, just to see what is the impact of this or how this variable it is created, to better understand if I get what I wanted to do or not. So here we have the total expenditure for all the years, and here we have this our new variable total expenditure 0, which is equal to the value of the total expenditure per capita in the year 0, and we have here a missing value. So now I wanted to remove this missing and keep only the values of the total expenditure. So I will add to the variable between the two. Again, if I want to show you what happens here, I will add the variable. Sorry. Here you can see that total expenditure has the values for each year, and total expenditure 91 has only the value of total expenditure of the value 91. I can remove this line where the year equals 0, and I can remove this column of the total expenditure 0, and I will have the two values of the total expenditure for 98 and total expenditure for 91. Okay, is another way of doing reshaping, but I am only focusing on the variables of interest. I don't want to change the other variables for now. So I will keep if year equal 1. Okay. And I will rename the variables, drop the variables that I don't want. And now if I will show you the data, so I have the household identifier. I have all the years equal 1 because I removed the other one. So I can drop the variable year. I have the total expenditure 91 in year 0 and total expenditure per capita in year 1, which is 98. So I have now, I can calculate the difference between the two expenditure, and here simply the difference between the 2 years will show me the evolution over time, which I can just start at the beginning without knowing if this related to the fact of being beneficiary of the program of microcredit or not beneficiary of the program of microcredit. So here I can drop also year. Okay. And I do the total, the sum of the two variables. So on average, the total per capita expenditure in 91 was 45 taka in Bangladesh, and 98. Of course, it is correct from inflation. and the average increased and become 58.87. Okay, we can observe that there are some outliers with higher values, very high values of outcome of income or total per capita expenditure. So it's better to use the log value of the total per capita expenditure. And in this case, if I want to calculate the difference between the 2 years, it will be the percentage difference. So I will calculate the difference in, the log of these values, and I will calculate the difference. And here I get that over the 2 years, because this difference between the total expenditure per capita in log form in 98 and the total expenditure per capita in log form in 91, for some households it decreased by 1.2%, while for other households it increased by 2.2%. So we can see that without controlling for who had been treated or who had not been treated, some households observe their expenditure per capita increasing and others observe that it decreased. So the first thing, if I want to now to control for the participation in the program, and again, this is a very simple way of see if there is a difference between household beneficiaries of male microcredit and others who are not beneficiaries. Very simple, just to test if there is a difference or not. Okay, so I will use the t-test command over this total expenditure per capita difference, the difference in both, see if there is difference between total expenditure per capita in 98 and total expenditure per capita in 91 I will differentiate by the households who benefit from the male microcredit and the household who didn't benefit from the male microcredit. They may be benefiting from other microcredit, but now I want to focus only on the male microcredit program. So it shows you here the number of observations who are not treated, who are not beneficiaries of the program, the number of observations who are benefiting from the program, the mean of the variable of interest, the standard deviation. We have the difference, so the difference is positive, and you have the test comparing the two mean. And here from the values of the p-values of the test, the t-statistic test, we can conclude what? That there is a difference in the total expenditure per capita of the households who have male beneficiaries and the households who have no male beneficiaries, or there is no difference, significant difference, I mean. Are you still with me, or I already lost you?
And they are not significant.
They are not significant. So by just simply comparing the mean of total per capita expenditure between households who benefit from the male beneficiary, from the male credit program, and the households who did not benefit from the male micro program, we can conclude that there is no significant difference between both. Let's do the same thing for female.
Racha?
So here I will use the t-test. Yes.
Racha?
Yes.
Hello everyone. Racha, I didn't get where you detect the unsignificant and that the two groups are not significant.
Okay, so the t-test command simply will apply the t-student test on the specific variable you are specifying and by the groups you are specifying for the command. So here I am asking Stata to apply t-test on the total expenditure per capita, on the difference of the total expenditure per capita between the 2 years, and differentiate between households who benefit from the program and the household who did benefit from the program. If you remember, this variable equals 1 if the household has a male benefiting from the microcredit program, 0 otherwise. So the results of this test give you the number of observations where the group equals 0, which means that they are not benefiting from the program, and the mean of the variable for this program and the standard deviation and standard error. For the variable, for the group who are benefiting from the program equal 1, we have the number and we have the average, and we have the difference between the average of total expenditure per capita in the in group 0 and group 1. In fact, here it is the average of the increase or of the change over time. Okay. And then here you have the traditional T student test. You have the mean of the group 0 minus the mean of the group 1. You have the null hypothesis that the difference equals 0, which means that there is no significant effect between the two groups in the change of the total expenditure. You have the T value, that is the value of your T statistic. You have degrees of freedom, and you have the alternative hypothesis. And from the probability, your P value, the 3 cases, you can conclude that you cannot reject the null hypothesis because the critical value is high. Your T value is higher than your critical value, so you will conclude that you cannot reject your null hypothesis, which is that the difference equals 0, and you conclude that there is no significant difference between the change in total expenditure per capita of the beneficiaries and the total expenditure and the change in total expenditure per capita of the non-beneficiaries.
Okay, great, Doc. In reality, this is can reflect any information. What type of information that can reflect these results?
Okay, so just by simply doing this, I can say that the households who benefited from the male micro-credit program observe their total expenditure per capita change, and the household who did not benefit from the program also observe over the years that their total per capita expenditure change. However, there is no significant between both. In other words, I cannot say that the households who has access to the male microcredit had an improvement or a change in their total expenditure per capita more than the household who did not benefit from the microcredit. I cannot.
So maybe in further projects like Karama or Takaful, we should not maybe integrate the variable of microcredit.
Yes, I mean,
Yes,
we can say this. No, yeah. I mean, here is different from Takaful. Here the main program is microcredit. Just from the statistics, I mean, I can conclude. I prefer not to recommend to use a microcredit or not, but I can simply conclude that given simple statistic, I cannot say that there is a group who getting more expenditure per capita compared to another group. Let me show you what is the situation with female microcredit and make it clear. So here I will do the same exercise, and here you can see just simply from the mean of the two groups that the change in the total expenditure per capita of the households who has female microcredit program is 0.25, while the change, or 25%, while the change in the total expenditure per capita over the years of the households who had no female microcredit is 0.14 or 40%. So just by looking at the two mean, we can observe that the change in the group of households who have female microcredit is more important compared to the change that happens in the household expenditure who has no female microcredit. And when we check the significance, we can conclude that yes, there is a significant difference. This means what? That the microcredit programs for female make the household who benefit from this have an improvement in their total expenditure per capita over the years. While for the male microcredit program, there was no significant change. So just by this exercise simply, I can conclude that yes, there was an improvement in the situation of the households who have female benefiting from the microcredit program. Is it clear? So this is the information I get. Can I really say that this improve is related to the microcredit? We cannot really now say yes or no because we know that it is not random. I just simply know that those who had a female microcredit, their expenditure change more importantly compared to those who did not benefit from the program. While male microcredit, it was not significant. Now, I will make like the movies suspense. We'll stop here, and after the break, we will see when we control for the non-randomization and we will control for the observable and unobservable characteristics that are not changing over time. Would really I conclude that yes, female microcredit have a positive effect on the expenditure of the household or not? This is what will be answered after the break. Any question till now? Okay, so now we'll take a break and we'll be back at 6:35, so 15 minutes break and to be continued after.
Thank you.
Thank you. Okay, hello everyone, we are back.
Welcome.
Thank you. ERF team, would you please stop sharing the screen so I can share mine? Thank you so much. Okay, so let's go back to our example. So as I said, by just simply comparing the average change in total per capita expenditure over the years between the individuals or the households who have no access to any credit, microcredit, and the households who have male microcredits, we found that there is no difference. There is no significant difference in the change over the years. While when we compare between households who has female who have access to microcredit and those who don't have access to the female microcredit, we have significant positive effect, which means that when households have access to female microcredit, their total expenditure per capita will be higher. Okay. So this here by only comparing the average without controlling for anything and without being sure if this increase or this positive effect is related to the fact of having this microcredit program or not. Another thing to do, we can simply regress the change in the total expenditure between the 2 years 98, 91 on the dummy variable that equals 1 if we have a male microcredit, 0 otherwise. So here I will simply, sorry, I will have to, okay. I will simply run the sample regression. And here you can see simply that having in the household a male who have access to microcredit have no significant impact on the change of the total expenditure per capita between 98 and 91. So by simple comparison of the mean using the t-test and by simple regression, we can say that having male microcredit program is not significant. While if we do the same things for the female microcredit program, we can see that having a female who has access to microcredit program have a positive significant effect. So now these two methods confirm us the same idea. However, as we said, this is non-random and we have a selection bias. We want to control this. Of course, before moving to using the difference in difference to control this non-randomization and controlling for the observable and the non-observable characteristics, here you can just find a section in your do file where we are doing the same thing, the comparison between the two mean and the two groups, those who benefit from microcredit male and those who benefit from microcredit females, while using the survey weight or the survey test. So it's the same idea. But now let's move to the difference in difference model. And here you have the same equation as what we saw in the PowerPoint. So we have here our outcome variable of interest. Let me add it to you, that YIT is the total expenditure per capita of the household I in period T. And this is outcome of interest. This is the outcome we are interested to see if it had changed because of our treatment program or not. Okay. DD here is the difference in difference coefficient, is the coefficient of the interaction between the treatment dummy and the time dummy as we wanted to see it in the slides, which is corresponded to beta in the slide. The B is the coefficient of the dummy variable of the treatment, and the treatment here, it depends if we focus on the male microcredit programs or the female microcredit program. And here the B corresponded to the gamma in the slide. I can write a G if it would be better for you. So here we use the gamma. And the last coefficient delta, the D, is the coefficient of the time dummy. In fact, we should not write It will not change with the individuals. I am sorry, so I will remove the I because it does not change with the individuals. The time dummy is 0 if we are in the year 91, 1 if we are in the year 98, and it corresponds to the D delta in the slides. And here I want you remember that we manipulate the data so that we have a number of household year 1, and we have the total expenditure for year 0, 91, and year 1, 98, and the difference between both. Now I don't want the data in this shape. I want it to the original shape, which is the long one. So I will use it back again. And because of the outlier and the large values of the total expenditure per capita, I will use the log. Okay. And now I wanted to create the dummy variables for the treatment and the dummy variable for the year to be able to estimate my model and estimate my coefficient of interest of the difference in difference. Okay. Well, so here I will create a dummy variable for the treatment, which equal 1 if there is a male who has access to microcredit in the household, which means that this household is treated. And in the year 1, which is the interaction between both. Okay. So this variable DMMFD1, this is the interaction variable that we had been talking about. It is the variable that equals value 1 if there is a male, which means benefiting from the microcredit, which means that the household is treated in year equal 1, which is the year 98. So this is the interaction between both variables. Okay. I'll just go this way. So now I have, if I will show it to you, household here. So this is the household identifier. Here the year you have 0 and 1. Here you have if the household is beneficiary or not, if they have a male beneficiary or not in general, in year 0 and in year 1. Okay, so here the DMMFD98 means that in year 98, if the individual is treated or not treated, and here the interaction between both. So if the individual was not treated in year 0, it will be 0. If in year 1, the household was not treated, it will be also 0. Here for the household, for instance, 11061. In the year 1, they had male beneficiary, so the interaction between both is 1. Okay, so this is what we created, the variables of interest. I will do the same thing for female programs because we wanted to compare male programs and female programs. And I will start with the basic model as we saw in the, if I will go back to the slide, the basic one without any covariates. So I have just the treatment dummy, the year dummy, and the interaction between both. Okay, let's now run our model. So I regress the total expenditure per capita on year dummy, the treatment dummy, and the interaction between both. What we can conclude from these results?
And there is no impact.
There is no impact of what exactly?
DMMF, DMFFD 98 and DMFFD year.
Okay, so these two variables have no significant effect. What
Yes,
this
the two
first variable, okay, and this first variable DMMFD 98, what does it reflect? Rafida.
The treatment in this year.
So the treatment in year 91
in 9, yes,
has no significant effect on the total expenditure per capita of the household, right? Who agree on what I'm saying? Are you with me?
Yes.
So again, so this variable means that the treatment being treated in 98 has no significant effect on the total expenditure per capita of the household. Do we all agree on this? Okay. And what is the DMFDYR? This is the interaction term. Is this what we want? No, we said that the average treatment of treated, that the effect, if we want really to conclude if the treatment has a significant or not significant effect, we have to look at the coefficient of this variable, the interaction. So this variable has a significant or not significant effect on the total expenditure per capita?
Is not significant.
Not significant.
Has no impact.
So the result using the simple t-test to compare between the average of the total expenditure per capita of the two groups of households and the results of the simple regression and using diff and diff shows us that having a male beneficiary in the household of microcredit have no significant effect on the total expenditure per capita. What is this first line, this first variable here, is significant or not?
Is significant.
It's significant. And what does it mean?
The other years
What does it mean the other years?
without treatment.
No, this variable
the-
here equal 1 if we are in year 98, 0 in the year 92. Here I'm not talking about treatment at all. Here I'm only talking about the year. So if the variable, the dummy variable of the year is significant, this does mean what?
Is the impact of time? No?
Yes, yeah, which means,
Yes.
can you explore more, please, Racha?
Yeah. The year represents time.
Yes, which means that when we are in the year 98, what would happen to the total expenditure per capita compared to the year 92?
Is this the alpha or
No, this is not the alpha. The alpha is the constant term. This is the delta.
the delta? Yes, yes.
This probably means that it means based so in comparison with the reference year, it does explain the variation in the dependent variable. In this case, this is why it's significant, basically.
I'm not sure I get your point, Hassan, because
Right. Let's say, I mean, I'm not sure what year is this exactly, but of course this is
98.
variable, right? Okay, 98, and it's taken against a reference year,
Which is 92.
which is 91. Yes. So in the case of 98, then yes, the year would explain much of the variation in the dependent variable in this case. So, and I think this is pretty much related to the treatment.
No, so let me clarify something again. The variable here, and if I will go back to the slides, let me just bring the both together. I'm trying to see how to do it. So the gamma shows us the effect of being treated, and we know that the treatment will be in year 98. So just the fact of the effect of being treated without taking into consideration the year, what would be the impact on the outcome of interest, which this gamma correspond in here in my table to this variable. And it is not significant, which means that being treated or being participant in this program of microcredit would not affect my outcome of interest, which is the total expenditure per capita. Okay? The delta, which is the coefficient of the year, of the dummy of the year, and here it corresponds to this coefficient. So here this variable year equal 1 if we are in the second period, which is 98 compared to 0, it is positive and significant, which means that a part of being treated or not, being in the year 98, total expenditure per capita is higher compared to the total expenditure per capita in the year 91. Whatever the status of the household is, whatever they are treated or not treated, just being in the year 98 we have higher income compared to higher total expenditure per capita compared to the year 91, whatever the treatment situation is. Which was, if I return here to the to my figure, if you notice here that the 2 points in the year after, okay, they are higher compared to the original one. No, even without treatment. Only the fact by time I saw my income by total expenditure per capita increased simply because of the effect of time, indifferent from the fact if I am in the treated group or not treated group. So here the interpretation of this variable year, that it is positive and significant, that being in year 98 increase the total expenditure per capita of the households. And we cannot say anything about the treatment. And the variable DMMFD98, which is the dummy variable for the treatment, says that being treated has no significant effect on total expenditure per capita. Being treated means that having a male microcredit beneficiary in the household have no significant effect on the total expenditure per capita. However, my variable of interest using the diff method, the variable that will conclude or will give me the average treatment treated is the beta, which correspond in this analysis to the interaction between the time dummy and the treatment dummy. And this is negative, but not significant, which means that we can conclude using the difference in difference method that having a male beneficiary treated household in the year 98 compared to the year 92 has no significant effect on my total expenditure per capita. Okay, let me run the example for women and see the results, because here is different. Okay, here we have significance of the year and significance of the treatment. So being in year 98 would increase the total expenditure per capita compared to the year 91 without controlling. I mean, I don't know if the household is treated or not, but what I know is that being in 98, for sure, total expenditure per capita will be higher than total expenditure per capita in the reference year, which is 92. For the time for the treatment dummy and the interaction, and this is the coefficient I am more interested in. So being a household where we have a female microcredit, where we are benefiting from this program, we will have higher significant total expenditure per capita compared to the other household, which means that I can conclude that the female microcredit has a positive significant effect on the total expenditure per capita of the Bangladesh households. Okay, so again, the dummy year just shows you the effect of the year, which is the evolution over time. If it is higher, this means that in all cases you will have higher total expenditure per capita in this year compared to the year of reference. If it is negative, which means the opposite. But your variable of interest to conclude if you have really significant effect of your treatment or your program or not is the coefficient beta, which is the coefficient of the interaction between both the year dummy and the treatment dummy. Because this difference in difference coefficient control for the unobservable characteristics we talked about. It controls for this difference in the unobservable characteristics that are invariant over time. Is it clear?
Yes, and then we say that the beta, that treatment effect will be 0.11.
Yes.
Okay.
Okay, and of course this is in log, so you will have to multiply by 100. So being a female who is benefiting from the female microcredit will have their total expenditure per capita higher by 11% compared to if a household who has no female microcredit. Okay.
Okay.
And here, as you noticed, that using the simple t-test to compare between the average change in total expenditure per capita, the two groups, or using simple regression, or using the difference in difference, it confirms the same idea that we don't have a significant effect of having a male microcredit in the household, while if we have female microcredit in the household, the total expenditure per capita of the household will be higher, which means that this program, which is a microcredit for female, has a significant positive impact on the total expenditure per year, which is our variable of interest or outcome variable of interest. Okay, this here we are not controlling for any other variables that can affect our outcome, which is the total expenditure per capita, and can also affect the selection into the program. Okay, if you control for the observable characteristics in addition to the non-observable characteristics, you are sure that you are doing good job in comparing between the beneficiaries and non-beneficiaries. So we will add covariates, and here the covariates that we will add are the head characteristics, the household characteristics. So we have if the household have a land or not, and this is in decimal, so the value is very small, so we'll correct for this. We have the sex of the head, the age of the head, the education of the head. We have the characteristics of the village, if the village have access to roads or not, if the part of land in the village that are irrigated, and the prices of the expenditure of food, main products like rice, wheat, milk, edible oil, and egg, because all this we believe would affect the total expenditure of the household. We will control for this in addition to the time dummy and in addition to the treatment dummy. Okay? Let me show you the descriptive statistics of these variables. So I have it all for all the variables, and for the land because the values are very small. We will correct, it's in acre, we will correct for this by and we wanted to use the log land, so I will recalculate the land in logarithmic function. Okay, this, so now I can think that maybe, I mean, I want to control for the variables x. Why I want to control for these covariates? Because I know that they are affecting my outcome and they can affect my selection into the program, right? However, these variables, I mean, the area of land, the sex of the head, can change. If in 92 I had my husband and he was the head of the household, but in 98 my husband died and I became the head of the household. So in this case, my household was male-headed and then became female-headed. It's possible that it changed. The age, my husband has 30 years old in 98, and now in 98 have 37 years old. Education, he had no PhD in 91. In 98, he has a PhD. The prices of the different products. So all these variables that can affect my outcome can change over the years, no? So if I am concerned if these variables change or not over the years, we want to test if there is a significant difference in these variables between 98 between the different groups. Again, if you remember when we were using the PSM, we wanted to be sure if there is a difference between the variables that we select between the treated and the non-treated groups or not pre the treatment. Here's the same idea. I want to know if the variables X I am choosing to control for in my model, they were already different between the participant and non-participant in the program in the base year 91 or not. Okay? So what I will use a command which is called tab form. This command, as we will see, will produce an Excel file, and this Excel file will show us the means in the value of the variables between the group who are treated and the group who are not treated. Okay, so the command is tab form. All the variables I wanted to include, I am using the weight to correct to have the weight and talking at the national level. I wanted to do it at year 0. Okay, I will save the Excel file in my file where I am doing my analysis. And let's change the date to have the date of today. So we are 5 March 2024. And by I will use the variable of the treatment, which equal 1 if I have male beneficiary and equal 0 if I don't have beneficiary. And I add the option M test, which means that I wanted to add a T statistic for the comparison between the mean of the different variables. Everyone is following what I'm doing? Or I lost you, all of you?
Yes, yes.
Okay, sounds perfect. So I will run. Okay. It produced the Excel file, which I don't know where it is. Why it's not. Oh. Second, let me close this and open it again. Okay, we come back. Okay, for some reason I couldn't find it in the same file, so I look for it on my computer, and here it is. So here, I'm saying too much. So what this command produce? So you have here, this is your treatment variable, which is equal 1 if you have a male beneficiary in the household, 0 otherwise, okay? And here you have the different variables you are including in your model. So you have the land area, you have the gender of the head, you have the age of the head, you have the head of the household education, you have the village, if they have access to it or not, and the prices of the village, also the price of different products in the village, okay? And you have the significance level. What do you notice from this table?
We can see that some variables are significant, but other no.
Exactly. So for some variables like the land area, the household gender, the household education, and the years, you have significant difference between the group of the beneficiaries who have male microcredit and the group of non-beneficiaries who have no male microcredit, right? This means that, and this comparison is at year T equal 0, which means the year 91. This means that pre the intervention, pre the implementation of the microcredit, there were already difference in the characteristics between the beneficiaries group and non-beneficiaries group. And this is important to know that, okay, so we need to control for these variables and include it in our model because they will make a difference. Because these variables were different at period 0 when the base year before implementing the program, and it can affect our results. So it's a good thing to do that we are comparing or controlling for in our model. You notice that for some variables at education of the head or the area of the road with access to road in the village or the irrigated land, and some prices were not significant difference between the two groups. So at least you know that what are the variables that have been different and what are not being different. Okay, I will do the same thing. So here I'm saying that there are significant difference with the treated owing less land. Remember that our threshold, that the households who can benefit from the program of microcredits are the households who have less lands than 1 acre compared to the others. So having less land make you give you the credibility to access this program. I will do the same thing for female. Let me change also the year, so you will have your results correct. Okay. I will look for it on my computer. Here, the Excel file. Same thing, we observe that the treated group have less land, which is expected given that we know that the criteria of the being selected in the program that they have less land. They have female-headed household. There is no difference here. There is no difference in the age. The age is not significant difference between the two groups. They are younger. The beneficiaries households have younger head. No, this education. So they have lower years of education. There is no difference in age. I'm sorry, there is no difference in age, but they have less education. And there is difference in the irrigated land that they are living in villages with higher area irrigated. So again, this command or this exercise allows me to compare between the variables, the covariates that I observe, and I think that they change over time, and they can affect my outcome and affect the probability of being selected into that program. So I wanted to see if there were difference in these variables before the intervention at the period t equals 0. And when I run this command, I can see that the beneficiaries have less land. They are mainly female-headed households, so they have access to female credit. They have less years of education, but they are living in villages with more irrigated land. So I know now that there are differences in these characteristics before the intervention or the benefiting from the program. And it's really important that, again, in addition to better understand the data, it would allow us to see if there was a difference between the beneficiaries and the non-beneficiaries before the treatment or not. Okay? And given this, that we saw that for households who are female-headed, whose head younger and the head have less education, are benefiting from the program, and those who have male head have more years of education and more land have not been selected on the program, we can conclude that we don't have a randomization at all here. The selection into the program is based on these characteristics, in addition to the non-observable characteristics of the household. This means that we need to use a diff and diff to be sure that we are really taking into consideration this non-randomization, controlling for the observable and unobservable variables that are not varying over time, to be able to conclude if our treatment or our program is significantly changing the income, the expenditure of the households or not. Okay. We can also compare how the difference evolve over time. I will create 4 groups. I will create a variable with 4 groups: being controlled in 1991, being controlled in 1998, which means it's are the individuals who have not benefiting at all from the program, and the treated one when they were in 1991, and the treated one when they were in 1998. So I will create this variable, okay, for male and for female. So here I can have that, I know from the sample how many were controlled in 91, 98, how many are treated in 91, in 98. Here just to show you what I created by this, with this variable. So this variable shows me in which year I am and if I am a control person or a treated person. I can do the same thing, so I will do the same exercise of the tabulation, but not by male beneficiaries and female, by male beneficiaries and non-beneficiaries. I want also to see it by years. I don't know if I am clear, but let me open this exercise, this Excel file again. So here in the first time I did this exercise, I was only comparing between households who are beneficiaries and households who are not beneficiaries. Okay. However, I may also want to compare not only by being beneficiaries or not, but also by years. I want to know if it changes over the years or not, these variables. So here I created this variable with different category by being controlled and treated for the different years, and I will run the same exercise, okay, for male and female. I will show only the female to compare the two Excel files. Okay. Okay. So here, as you can see, SATA creates the same table as the first one. However, I'm not only comparing between treated and not treated, I'm comparing between control and treated group in the different years. So you can also compare, for instance, for the control group, if I compare between 98 and 91 and 98, I can see that they have more lands. They were mainly male-headed household, and sorry, they were mainly male-headed household in 91. In 98, they changed, and this means that the head traveled or died, so the sex of the head changed. The age of the head also increased, and this is expected for the control and the treated, because we have over the years, if you compare the age in 98 is higher than 91 for both the treated and the control. Years of education for the control ones increased. This means that more studied or more increased their years of education among the control, but among the treated, no. Again, this confirms that it's not random. This means that the control who have now higher education, they didn't benefit from the program, while the non-treated, while the treated who benefit from the program did not change or have evolution in their education levels. So this exercise just to make you get an idea of the different variables that you are including in your model, if they are really changing over time and among the beneficiaries and non-beneficiaries or not, and ensure you that you are really here in non-randomized situation and you need to control for. Okay, now I will rerun our model, but by adding the covariates that we discussed till now. If I return back to the PowerPoint, now I am running this regression where I include the treatment dummy, the time dummy, and the interaction between both. This is the coefficient I am interested in all cases. However, to be sure that I am really controlling for all the unobservable characteristics that affected my outcome and can affect my selection into the program of being beneficiary of this microcredit program, I will include couple of covariates that we saw that affected my our results. So here, this is my regression. I'm adding the year dummy. I am adding a dummy for the being treated in 98. I am adding the interaction, this beta B0 dot, to tell SATA that this variable is binary. Same things for B1. And then I have continuous variable, the age of the head, the education of the head, the area of the land, the village have access to roads or not, and the prices of the different products. And I am using weight and action here dummies, but also for the other regressors. If anyone had noticed the R squared increase, still of course it is low because these are not all the variables, but this is just for sake of exercise. But of course the R squared increased because we have more variables. What can we conclude from the results here? Here, our treatment is having a male beneficiary in the household of the microcredit programs. So what can we observe here? What we can conclude here from
Can
these
we
results?
scan the screen? We can't see.
You can see my screen. It's weird because I was already sharing my screen.
We can. I think the problem's from the participant.
Yes, we can see it.
Okay, perfect.
Yes, we can see that some variables are significant, but others no. For
Okay, perfect.
example,
So,
education and land are significant.
the education
Also,
of the head and the land, the education of the head and the area of the land, the household have significant effect on the total expenditure per capita.
and the price of milk and eggs.
The price of milk and the price of eggs are have also significant effect on the total expenditure per capita of the household. Okay, did the effect of the year change compared to the initial model where we didn't have any variables?
Is also significant.
Yes, and so it's significant
the
and
other.
positive. Yes, like the others exercise. What about our variable of interest, the interaction between the year dummy and the treatment dummy? Did it change?
No, they are not significant.
So using t-test or using simple regression or using the diff and diff with covariates or no covariates, we can conclude that having a male beneficiary of microcredit in the household would not affect the total expenditure per capita of the household. While if I will run the regression again, but for female participant of the program, here you can see the year is still significant. What does this coefficient mean? Or what changed?
It's not significant.
It's not significant anymore, no?
Yes.
If you remember, it was significant in the if I will run it from this model, that having a female participant in the household have a significant effect on the total expenditure per capita of the household. While when we controlled for other observable variables, we found that this effect is not any conclusion. Again, when we regressed our total expenditure per capita on the year dummy, the treatment dummy, and the interaction between both, we concluded that having a female participant in the household would increase or would have significant positive effect on the total expenditure per capita. However, now when we controlled for other variables, we found that this variable is not significant anymore, which means that having a female treated household, having a household with female who have access to microcredit, which means that they are treated, would not significantly affect the total expenditure per capita. What does this mean?
That means that the program has no impact comparing the other variables, covariant.
Exactly. This means that when we controlled for other variables, like the age, the education, the sex of the head, the price, the characteristics of the village, we found that this program is not significant anymore. And this is really important because imagine that if you were to provide the Bangladesh government with recommendations regarding this program, and you didn't control for all these variables, and you tell them, yes, this is a significant program, you have to increase it or to have more beneficiaries, which is not the case. So here your policy implications is not correct. So this means that we need to control for everything that can affect our outcome. Like here in our examples, the individual and the household characteristics and the village characteristics, in addition to the diff and diff coefficient, to be sure that your results are robust. And as you can see, we already observed that all these variables were significantly different between male, not all of them, but most of them were significantly different between the beneficiaries' households and the non-beneficiaries' household. And when we include them in our model, the treatment effect is not significant anymore. This means that we can conclude that both male and female programs are not having any significant effect on the total expenditure of the households. Is it clear, this point? Any question? Okay. Now, let's move to the last points we discussed in the presentation. How we can use the diff and diff in cross-sectional data, not in time series data, in panel data, and how can we use also PSM and diff in the same time. So here we'll do the same exercise, but sorry, I'm doing here. Here I will use an example. I'm using the data only for the year 91, not the panel data, because I wanted to show you that we can use a difference in a cross-section data, not a panel data. I will focus on the year 91. If I show you the data, here you can see that we have the same households, but for 1 year, the year 0, which is 91, and we have all the variables and all the characteristics we had before. Okay. As I told you, if I return to the presentation, that when we are using the diff and diff in cross-sectional, instead of using period 0 and period 1, I will use geographical location instead of the time. And this geographical location, we should have villages or geographical locations that had been that had the program or where the program is implemented, because you know in most of all countries, when they want to implement a program, they will not implement it everywhere. They will focus on some geographical locations where maybe poverty is higher, where they want to create more jobs. It depends on the programs. So we'll have villages or geographical locations where there is no program, and others there is program. The villages where there is no program, I will consider it as if they are the period 0, and the villages where there is program, I will consider it as the period equal 1. I'll turn back to my data. Here, as you remember from the beginning, we said that we have a village identifier, and we have smaller decomposition of geographical locations than village, which is we call the SANA. So we have SANA ID and village ID. There's no point to, I will show it to you. Okay, so we can see that we have villages, and villages are decomposed in, SANA, and the SANAs are decomposed in village. So SANA considered as, for the case of Egypt, for instance, governorate. And we have the household, okay? Instead of having an identifier for the SANA and an identifier for the village, I will create new identifier for both. So I will have for each household one identifier which is composed from the SANA ID and the village ID. Okay, this is how I will generate it. Let me show it to you. And the village here. This is a household identifier. You see that here, instead of having an ID for the SANA and an ID for the village, I create one only identifier for the first number shows me the SANA, and the second one the village. Okay. I will do here. I am repeating the same things as I did before, because I am using a new data set for 91. So I am calculating the log expenditure for the total expenditure per capita, and I am also for land. And now I want to differentiate between, in the time when we are using panel data, I have period 1 equal 1 for the new year where the implementation of the program is satisfied, and base year, which is a year 0. Now I want to differentiate between village where the program had been implemented and village where the program had not been implemented. Okay. What is the threshold? If you remember, the threshold or the cutoff was based on the land area. So I will create a new variable. I will call it target. This target equal 1 if the household own land less than 50 acre. This was the cutoff criteria of the household to be benefiting of the program or not, or to be targeted to the program or not. So I will create this variable, and just to be sure that I am doing good job, you can see that here the variable target equals 0 if the household land is between 50 and 4618. This means that this household have large land, so they don't need to be targeted by the program, while this household will be targeted by the program if they have less than 50 half acre, which is here reflected by 50 decimals. Okay. So here, this is our participant, this is our participant, and these are non-participant households. So this for the beneficiaries and non-beneficiaries. Now for the village, we, based on the literature and on the program, they said that, okay, I will define the village who are targeted by the program, which will assume that they are the year equals 1. Those are the village who have an ID larger than less than 25. So assume that the Bangladesh governorate would rank all the village and all the ID and said, okay, I will take the first 5 villages or the first 10 sanas, and those are the ones who will get benefit of these programs. Okay, so instead of having year 1 and year 2, now, year 1 and year 0, now I have the village who are less than 25 who in the order, so they will be benefiting from the program, and those who are larger than this will not benefit of the program. This means that if you have the cross-sectional data and you want to use diff and diff, you need to know what are the geographical area where the program was targeted and the households were targeted, and where are the governorates or the geographical areas where there was no program, to be able to distinguish between what we call it program village or geographical area 1 as year 1 and geographical area 0 as year 0. So here I will do the same thing. And if I tabulate this, you can see that we have 85% of the villages are targeted by the program, which we consider as year 1, and 15% are 0. So this is the beneficiaries or treatment dummy. This is the village dummy, which corresponds to the year dummy in our analysis. And now I will create the interaction between both. This is our variable of interest. So again, I'm applicating this regression. The treatment, I differentiate between the households who had been targeted because they have an area of land less than 50, than half acre, which is 50 decimals, and 0 otherwise. Instead of T being the time 0 and 1, it will be 1 for the villages who had been targeted by the government and 0 for the villages who had not been targeted by the government, and the interaction between both. Is it clear? Are you following? Did I already lost you? I hope not. Would you give me any signs that you are still with me? Please.
Yes, I am.
Okay, thank you. Thank you, Rashid. Okay, so now we created the time dummy or the village dummy instead of the time dummy because we are working on cross-sectional data. we created the targeted and non-targeted households based on the cutoff of the land area, and I create the interaction between both, and I will do the same thing as we did before. The only difference, instead of having beneficiaries and non-beneficiaries, I have targeted group and non-targeted group, and instead of having time, I have villages and non-program villages. I will run my regression, and here, as you can see, we found that the program village, which is correspond like the idea of the time dummy, is not significant. So being in specific, being in a village where the program was implemented compared to the village where the program is not implemented, have no significant effect on the total expenditure of the household. Being a targeted household, which means that being a household with a land less than ½ acre, would have a significant effect on your total expenditure per capita. And as expected, when you have land less than ½ acre, which means that you are poorer, which means that your total expenditure is lower. While our variable of interest, which is the diff in diff coefficient, which is the interaction between the treatment effect and the geographical location effect, which is the time effect, we have no significant effect. So we can conclude here that in year 92, the program of having male beneficiaries in the household to have microcredit would not have significant effect on the total expenditure of the beneficiaries. Okay? But again, here I am not including the variable, the other variables that we know that may affect the households expenditure and their beneficiary from the program. Here I just know that, okay, being poorer, I will be targeted by the program, but the program will not have significant effect on my total expenditure per capita. But I did not control for the other variable. I will run the same regression, but by including all the variables we know about it. And because I know that some variables that are at the village level will not vary among the level, if we are all living in the same village, we are all facing the same price of rice, the same price of wheat, the same price of milk, everything. So we will cluster our standard errors at the village level because we know that the variables will not change over the observations living in the same village. And this also we did it above, but I didn't, I forgot to mention it to you. If I run my model, we can see that when we control for the other variables, the program village dummy variable is not significant anymore. What is significant, as expected, the education of the head and the area land of the head and the price of milk, and it's only the price of milk. So this means that in this data in Bangladesh, in these years, education of the head and the area of land the household possess is significant explanatory variable for the total expenditure of the households. We can not conclude, given the analysis, that this program of microcredit have a significant effect on the total expenditure. Okay, so this is really important to be sure that you are including all the variables you think that can affect your analysis. If you don't have any question for this, I will finish this session with the exercise of using both methods, the PSM method and the difference in difference method. So we are sure that we are controlling for the observable heterogeneity of the initial conditions, that in the beginning, I am matching between those who are participants and those who are not participants, who have similar programs. It's not that there is any bias from the beginning in the selection. And then I will benefit from the fact that I have panel data to control for the unobservable characteristics that are not supposed to change over time. Okay, I will use again the data set, the panel 1, to return back to our diff and diff at the time level. Okay, I will create all the variables I created before to be sure that I have the land in log form. I have the dummy variable for the years and the dummy variable of the beneficiaries, and that I have the interaction for the between the year and the treatment effects. Okay, So now I am preparing, I have my data prepared. I have all the dummy variables I wanted to create for my different variables. But step one, before estimating our equation diff and diff, if I return to my slides, we will combine both. I mean, we will use the PSM to create the P-score. And when we create the P-score, we will use it as a weight to use it in our diff and diff regression. Okay. So now, after preparing my data, I will use the P-score command to prepare, to estimate the p-values. I wanted to save the P-score in this variable, this square. I wanted to focus, if you remember from last week, on those who are in the common support area. I wanted to be sure that I will only focus on the observations where I can match together. I don't want observations who are not on the common support area, who don't have similar probability of being selected. And I wanted to do this at a significance of level of 1%. Notice here, the last variable is the variable I created, which is the treatment variable for the year 98. Now I will create the score variable. So we have the results as we saw last time. We have this logic, our probit regression, and it created the P-score, and it gave us the common support area. And here, as you can see, we have the score variable, which is the p-value I needed to be able, in the PSM, I needed to match between the observations. Here, I will need to use it as a weight, as we discussed. And we have also the common support area. I wanted to keep the observations that are only in the common support area. Okay. And if I show you the data here, let me show you. So okay. Here I have the household in year 0. Keep in mind that we are doing the matching at year 0 because this is the year pre the intervention, pre the program. I wanted to be sure that I am matching individuals in base year before the intervention based on the P-score. Okay, so here what I did, my analysis was at the year 0, which is the year 91. Here I have if this household was treated or not in the year 98, I have the p-value and I have that they are on the common support area or not. Now I wanted to use this p-value to rerun my diff and diff regression, but using the weights, okay? But here in this data set, I don't have all the required variables because here I focused only on the variables of the year 91, the base year. So what I am going to do now from this data set, I will only keep the 2 variables I want, the household identifier and the p-value, which I call it the score. So I will drop all the other variables. Okay. Now I have for each household, what is the score of the p-value or the likelihood of being selected into the program. And then I will merge this data set with my original data set I had been working with. So as if I'm just adding a column to my initial data set with the value of the P-score, which corresponds to the probability of being selected given the characteristics at the initial year. Okay. If I tab merge, everyone is aware with the command merge and what are the results of this command?
Yes.
Okay, perfect. Thank you. I will keep those who are in the common support area because you remember we dropped some observations who don't have a p-value because they are not on the common support area. So now I have, if I will edit, you can see I have the household, I have the score of being selected into the program, I have the years, and I have all the variables I am interested in. Yes, we have the year 0 and 1. Okay, I will create all my variables of interest, the total expenditure in log, land in log, the dummy variables, the interaction between the treatment and the years. I will create the weight as we discussed last time, if you remember. I divide the weight. I will this part is the inverse propensity to score. Yes, Tahan.
Thank you, Racha.
Yes.
I'm sorry. I feel that I'm a little bit lost. My question is the question is about why we use the function weight, for which reasons, or maybe
Why we use the propensity weight?
yes, for which reasons, or maybe when we in which situations we should use this type of function.
Okay, so I got your questions. What is the point of what we are doing? When we can use both together? We talked last time that the propensity score matching, you use it when you have a cross-sectional data. And by using this method, you control for the observable characteristics that can affect the selection into the program and your outcome. So it's one way to overcome the problem of non-randomization that we had been talking about in our first session. And we said that the PSM, we can use it in 2 ways. You can create these P-score values and use it to match between the different observations. Then compare between the outcome of the matched observation, or we can use this p-value as a way to calculate a weight that we use it in our regression, where we just include a dummy variable for the intervention. Okay, this was what we saw together on last Tuesday.
Okay.
Today, since the beginning, we're talking about diff and diff, and we said that diff and diff, it's a way to control for the unobservable characteristics that are not varying over time. And usually you use it when you have a panel data, which means that you are observing your participant and non-participants over 2 periods in time. A period before the intervention and a period after the intervention. Now what I am doing is that I'm saying what? PSM control for the observable characteristics and allow me to be sure that the participant and non-participants are have the equal likelihood of being selected given their characteristics. And the diff and diff allow me to control for the unobservable characteristics. Why don't I match both together and get benefit of the 2 methods? Especially that if you remember when I show you the Excel file, you saw that pre the selection, there was a difference in the characteristics between the beneficiaries and non-beneficiaries. So what I am doing now is that I will start by doing the PSM. Okay, calculate the P-score for all the observations in the base year. So now I have in the base year the probability of being selected into the program, okay, given the characteristics of the individuals before the intervention or before the program. I calculate this probability and I will use this probability as we saw last time to calculate the, to calculate the weight. And if you remember, we said that we will give more weight to the households that were supposed, given their characteristic, to be selected, but they were not selected into the program. And we will give more weight to the households that, given their score, they were not supposed to be selected into the program, but they were selected into the program. So this is the inverse propensity weight that we'll use. I will multiply by the weight, the original weight in our data set. I will create new weight, which is the T weight. And then I will run my regression where I regress the variable of interest on the year dummy, on the treatment dummy, on the interaction between both dummies, on the different variables, and I will use the weight I am calculating based on my p-value or based on the PSM. Here, as if you want to get the benefit of the 2 techniques together to be sure that you are controlling as much as you can for any characteristics observable or non-observable that can be not changed over time, to be sure that when you conclude that the program has a significant effect or not significant effect on your outcome, you control as much as you can on the selection bias. I hope I answered your question, and it's clear for you now why you are doing this.
Okay, thank you.
Thank you. So again, after calculating the p-score using the PSM method, we have the likelihood of being selected into the program for all the observations treated and non-treated using the characteristics that we observe. Then we calculate the weight as we took last time, and we multiply it by the sample weight. And I rerun my regression of diff and diff, where I have the year dummy, and as we can observe, it's still significant. We have the treatment dummy and the interaction between both, and I can observe that still we can conclude that even by using the weight of the PSM, the program of microcredits for male have no significant effect on the total expenditure per capita of the household. So whatever the model, whatever the techniques I am using, diff and diff, and PSM, simple comparison of the means, I always conclude that having microcredits for male would not change my total expenditure per capita as a household. We'll do the same things for female households to show you. I repeat the same steps, and here we observe the same thing as we observed before. When you control for all the variables related to the head characteristics and to the village characteristics, we found that having a microcredit program have no significant effect on the total expenditure per capita of the household. And with this, I will close my log file. Okay, and let me go to the log file we created. What's its name? It's DDV1 file log view. Okay, DD. Oh, okay, sorry, I need to open it from the folder itself. Here it is. Sorry. So here how the log file looks like. You have all the commands and the results of the commands. So you can observe if you want to share it with your supervisor or with your co-author, or if you wanted to keep it so you can later on check at it and be sure what you have done. So you have all the commands and you have all the results of your session of what you did. Okay, with this, I will finish the session here. I don't know if you have any question, comments, remark on this session or in general on the workshop.
Yes, Racha, I have a question in general, please. I usually work with micro-level data, but firm-level data. In many of the models that I use in firm-level, I'm not requested to use weights for observations or for different firms, probably because of the World Bank sampling method. I can notice, in the data used by the ERF, especially household data, weights are used to a large extent. Is there like any methodology I can get from ERF, like some document that probably, delves a bit more about the weighting issue? And when is it not necessary to use weights in micro-econometric techniques? When is it necessary to use weights, etc.? So, like, could you help with that respect, please?
Yes, so usually you use weight to be sure, all the data we are using, at ERF and like the ELMPS data, for instance, or if you are using the hikes, the household expenditure surveys for any countries, these surveys are nationally representative. Okay, so when you don't use the weight, it means that all your results are based on the sample you have only. You cannot generalize. So let me give you an example. If I calculate the poverty rate using the household survey in Egypt without weights, I cannot say that this is the poverty rate in Egypt. because I'm not using weights. I cannot generalize at the country level. If, for instance, I found that the number of the individuals using takaful, benefiting from takaful, are 50%, assume, but I am not using weights, I cannot say that 50% of the population in Egypt are using weights. If you don't use weight, you are only working at your sample level, because the weight shows you each observation, how much it represents nationally. So when you use weight, so you are able to generalize your results at the country level. And and usually, I mean, I am saying usually because sometimes you can get access to some data, micro data, especially at the household level, without weights. And here you have to pay attention when you are doing your analysis. You cannot say in the country X. You will say my sample, so 50% of my sample or 10% of my sample are getting benefit from this program. Okay, so this is the main idea of the weights that allows you, in national representative data, allows you to generalize for, to talk about, to calculate your results, even the descriptive statistics at the national level. In all the data sets available at ERF, you have documentation regarding everything, how the weights are calculated, how you are using it. So you have all the information for each survey. You have all the documentation related to this.
Obviously, the survey at the RF will provide us with the weights, right?
Yes.
They're given in the survey.
Yes.
Okay. Okay.
You find
Okay. Thank you. Thank you.
Thank you. Tahani?
Thank you, Racha. I want to benefit from your expertise and have an idea about the type of data. I heard that you talk about cross-sectional data. You talk about other types that I can't detect the name. So can you quickly give us an overview about the type of data and maybe research that in which we can get more information about difference between those types of data.
Okay, so cross-sectional data, as I mentioned, is the data that you have several observations at a given point of time. For example, the demographic and the health survey, because I remember in the first day, a lot of you said that they are interested in women empowerment issues. So usually we use the DHS. The demographic and the health survey, as far as I know, in Egypt and in Jordan and in other Arab countries, they are cross-sectional data. So we have the data on 2014 on specific number of women, and we don't follow up with these women. The data I have in 2008 for 100 women, for example, is not the same as the data we have it in 2014 for another 100 women. So this is a cross-sectional data. Since as far as I know, for the data I am working with, for the DHS, it's cross-section, it's not panel. For the I have each year number of individuals or number of households, but they are not the same households. So I can, if I have the household expenditure data in 2015 and 2020, I can observe the change in total expenditure in general for some characteristics, but I cannot say this is the same household because they are not panel. Okay, this type of data cross-section. The panel data, and the famous example, which is a huge fortune for researchers in the region or anyone working on the region, is the Egyptian labor market panel survey data, and on the ERF website, and also we have it for Tunisia and Jordan. So here you have the same individuals you observe over time. So if I take the example of the Egyptian labor market panel survey, I have it for 1998, 2006, 2012, 2018. You can follow the same individuals over the years. So you imagine, for instance, for those who are interested in female labor force participation, you can see the same women when they were single, when they get married, when they having children. So you can observe if their employment status change or not. If they join the labor market and then go out the labor market when they were married or when they are pregnant, what happens to them. So panel data, you have the same individuals or the same firms over the years. You follow the same individuals over the years. It's very rich and very interesting because you can use the diff and diff, as we mentioned. You can observe the change in the individual's behavior or status based on several characteristics. This is another type of data. Usually, if you are, I'm not a macro person, I'm a micro person, but if you are a macro person working on macro variables like GDP or trade, you will be using time series data, so the same variable observed over years. You can still construct the panel data using countries. And here, for instance, I recently have a working paper at ERF where we started female labor force participation in emerging economies. And here we constructed a database panel data from the World Bank. So we have the indicators for different countries over different years where we analyze, but here it's not really micro data. So these are different types of data that I am used to work with. And again, I feel that I'm doing the advertising for ERF, but this is true. The data section at the ERF website, you have huge sets of data for different countries in the regions, covering different topics. And if it's not the panel, it's cross-section, so you can use it for answering several questions. So these are different types of data you can use, Tahani. I hope this answered your question. Yes, and thank you, Namis, for sharing the ERF data portal link. I highly recommend you to go to use it. It's very rich. Rashida.
Thank you, Dr. Racha. Please, I can't run the do file because I can't specify the direction of the file.
Again, this tool line,
yes,
you have to change it.
I have a problem with the global original and also global thumb direction.
Again, you have to change, this red part is the path on my computer. So you have to remove all this. So the first one, you remove all this and you will put the path on your computer. Yeah, I mean, let me show you something. When you go to a file on your computer and you make right click, I'm not sure with Windows, but I think it will be the same thing. Get information. Here is the path, which means where the location of this file on your computer. You copy this path and you paste it here on you. So this is the path on your computer. So you have to go to see where did you put the data I sent you, and you use this path to put it on the original data here, okay, in this line. The global temporary directory is where you wanted to save your data. I create new file called app Micro-econometrics workshop, and in the middle, and in this file, I create new folder. I call it training March 2021, and I keep it 2021 because I'm keeping in the same file since 2021. So here is, and you cannot, I mean, it's possible that you don't want to use these two commands, and every time you are using a file or saving a file, you write the whole path. Just again, because as Chahir said in the beginning, and as you have noticed, sometimes you will change your computer, you wanted to change the file, to share the file with your co-author or with your supervisor. So it's easier, especially for someone like me, who, as you noticed, I like to save several versions of the file instead of changing the path every time I am saving the file or every time I am using the file. I prefer to have these two lines. So when I will send the file to Chahir, he has simply to change these two lines and put the path on his computer. So if you do this correctly, you can simply run the whole exercise. If not, as I told you, you can use it and save it every time by writing the whole path. I hope this helps.
Thank you, Racha.
Thank you.
I will do
Any
this.
other comments, remarks, anything? Okay, so if not, again, thank you so much for participating in this workshop. I hope you found it useful. If you have any questions later on, or if you want have any requests, please don't hesitate to contact us.
Thank you,
Nabil?
Rasha.
Thank
يعطيك
you
العافية.
very much, Rasha, for this training. It's very useful for us. Thank
Thank
you.
you so much. ERF team, Namis, do you want to say anything, or we are okay? Thank you so much.
Thank you, Rasha, so much. Thank you very much.
Rasha, I have a question, please.
Yes, sure, Fatiha.
Thank you for this workshop. Is really very useful. My question is about the data, microdata, especially microdata about income. In Morocco, we have a problem with microdata. You know that especially the data about income is sensible, and it's not open access, you know. And about this approach, if we want to, especially to apply it about income, we should just to evaluate, especially like a public policy about income, and it's not open. So my question is how we can to do a small data about international data about income, especially data of bank world, and relate it with some specific variable to apply it. And my second question is about the limit of this approach. You know that, Madam Rasha, every approach, econometric approach or modeling have some limits. So what is the limit of this approach, PSM especially, to analysis, for example, or to evaluate public policies, especially fiscal policies or social policies? And thank you for
Thank you, Fatiha. So let me see if I got your questions right. So first of thing, most of developing countries have no income data. We use expenditure data as a proxy of income. Especially that, as you know, in our region and in most developing countries, informal sector is really important. So you don't have really data on income. So usually we'll use expenditure data as a proxy of income. Okay.
Yes.
Most of the analysis we studied, the techniques we studied, and if you wanted to analyze the impact of any social policy or fiscal policy or individuals' income proxied by expenditure or on poverty or inequality, you need to use micro data, nationally representative, which is in our countries is a household expenditure data, which is not always available. I don't know about Morocco. I'm not sure if it exists on the website of ERF. Or I know that it's not publicly available, but the same thing for Egypt and Jordan. But I know that there are some surveys of household expenditure for Jordan and Egypt, for instance, are available on the ERF website. If they're not available and if you don't have access to your country, it will be very difficult to apply the method or to answer the research question. As I always said to my master's and PhD students, we always have interesting ideas, but you need to be sure that you have access to the data. The data exists first, and second, that you have access to this data, because it's not always the case. The data available on the World Bank website are usually macro data. So even if you have, for instance, expenditure per capita, you will have the average expenditure per capita for Egypt, for instance, or for Morocco over the years. You have the poverty rate for Egypt and Morocco and all the countries over the years. And with this data, you cannot do such analysis, because the techniques we studied in this workshop, and a lot of techniques, especially if you wanted to measure a specific social policy on income level or on poverty or on, for instance, women empowerment, you need to have micro data. You need to have the data at the individual level and as a household level. So if the data is not available and it's not existing, and if it's available or not is one question, and if it's accessible or not is another question. So yes, so this
we don't have the access to individual revenue, especially income. We have just a consumption variable, like
yes, but this is
probable revenue or something like this. It's the
Yeah,
only.
but this in most developing countries.
Yes, that's why we have this difficulty.
Yeah, but usually, I mean, it's acceptable, and in a lot of published papers that you use expenditure as a proxy for income to make such analysis regarding public policies and its impact on poverty or inequality on women empowerment. So I mean, it's commonly used. It will not be, yes, it's limitation, but if you don't have the data, you cannot, I mean, especially that. Yeah, I mean, for instance, if I talk about the hikes, the household expenditure, income, and consumption survey in Egypt, which I used a lot in my work, in the original data conducted by the Bureau of Statistics of Egypt, CAPMAS, the data on income is missing simply because, as we all know, a lot of persons don't want to answer about this question about their income, or because they are in the informal sector, or they prefer not to do this. So what we do is that we use the expenditure or the consumption as a proxy. So it's common, and it's not supposed to cause a problem for this. Any other question, remark?
Thank you for your explanation. Thank you for this workshop.
Thank you so much, and I hope you enjoyed it, and see you in other workshops and other events, inshallah. Thank you.
Thank you, Racha. See you.
Thank you.
See you.
Thank you.